Okay, so here I am describing the process of a neural transmission. And so what happens in the nervous system is that it operates as an electrochemical process. An electrical charge moves through the neuron itself, and the chemicals are used to transmit information between neurons. Within the neuron, when a signal is detected by the dendrites, it is transmitted to the soma in the form of an electrical signal, and if the signal is strong enough, it may then be passed on to the axon and then to the terminal buttons. If so, the terminal buttons are signaled to emit chemicals, aka neurotransmitters, which communicate with other neurons across synapses. So when this happens, it's in the axon, which is this guy right here, or like this whole thing, but yeah. And this is the dendrite, and basically what the process is so that normally a neuron is at the resting potential, which is a state in which the interior of the neuron contains a greater number of negatively charged ions than it does the area outside of the cell. But when it's doing a neural transmission, it's in the action potential, which means that the change in electrical charge that occurs in a neuron when a nerve impulse is transmitted, and it happens when the cell membrane opens its gates, allowing positively charged sodium ions that were previously kept out to the center. And there's a refractory period after the axon fires, and so it's like kind of like flushing a toilet. There's like a brief time after the firing of an axon in which the axon cannot fire again because the neuron has not yet returned to its resting potential. Reuptake is a process in which neurotransmitters that are in the synapse are reabsorbed into the transmitting terminal buttons, ready to again be released after the neuron fires. Exocytosis is a process by which a cell directs the contents of secretory vesicles out of the cell membrane and into the extracellular space. And depolarization is a change in a cell's membrane potential, making it more positive or less negative. In neurons, a large enough depolarization may result in an action potential. And a threshold is a limit below which a stimulus causes no reaction. So here we have this is the axon, this is the dendrite, and these little green circles right here are vesicles, which contain the neurotransmitters, and the neurotransmitters are every single one of these little red dots is a neurotransmitter. And so it goes, they're in the little green guys right now, and then they exit from the axon, and there are little like lock and key receptors at the outside of the dendrite, which is there to detect for them. And so they go from this little spot, and if it fits, it'll go into the receptor, into the dendrite, and then depending on what its purpose is, it can go through to another one or not. And that is basically what a neural connection looks like.